Hello everybody and welcome to a new episode of my series where I contribute to open source projects. This video will be part 2 of my attempt to fix an ST concurrency bug inside Parse SDK for Android. Now, if you haven't watched part 1 yet, then this video will not make much sense for you. Therefore, go back please and watch the part 1 before you proceed with this one, and I will put the link in the description of this video. So let's straight away jump into the code. Just to remind you, in the first part of this tutorial, I created this new unit test, fetch async concurrent calls success. And now if I run these tests of Parse file controller inside Parse SDK for Android, one of them will fail. This new test will fail, and the failure is well, now it's different from what we've seen in the previous video, and actually it's much more similar to the failure that I reported inside Parse GitHub account. So you can see that, file not found exception, source does not exist. Now let's jump quickly to GitHub and review my bug report. So that's the issue that I created. And here I put this stack trace which says file not found exception, source, and does not exist. And that's exactly the error that I get right now. File not found exception, source, and then does not exist. Now you might wonder, why the hell did I get another error, different error in the previous video, and now without changing anything I get this error? And that's just the manifestation of the fact that this bug has to do with concurrency, and most probably it is affected by the steps that are performed inside this unit test while it executes. And since we are doing stuff concurrently, there's this scheduling question, how the CPU scheduler will schedule these threads, and therefore the outcome of this unit test is kind of unpredictable, and it can fail this way or it can fail another way. But actually I'm very happy that we see this exception. It means that this unit test reproduces exactly that specific bug that I reported, and therefore if I manage to fix that, I'm confident that I fixed this bug. So now I have just this unit test and this code that doesn't work, parse file controller. Now this save async method is, this one. Let's admit it's very ugly. You see this huge nesting, and to be honest, I don't quite understand how it works. So we will kind of try to understand what's going on together, and then we will try to enhance this method to make sure that the bug is resolved. Now, the very first thing that I want to do here is to make sure that this class, Parse file controller, when it's used inside Parse SDK, is kind of a singleton. There's just one single global instance of this class created, because what I'm going to do is to introduce a shared state. I want to access some kind of a state between executions of these fetch async methods. And therefore, I must ensure that when this fetch async is called from multiple parse files, the same object will be involved. So how can we do that? Just let's scroll up and find the constructor of this class. Here it is, parse file controller, and see where it's used. It's used inside its unit test, of course, and in just one single other place. And here we can see that that's basically a singleton, right? We have parse file controller, get file controller, and if it's null, then we create a new one and put it inside this file controller. And of course, this get file controller is called on this get instance singleton parse core plugins object. Therefore, in this case, everything is fine, and parse file controller is kind of a singleton. There will be just one single instance of parse file controller, and therefore I can have a shared state inside this class, which will be shared between multiple parse files when I attempt to fetch them concurrently. Okay, that's absolutely amazing. Now let's understand what's going on here. I looked a little bit on this tasks framework, which is kind of com.parse.bolts internal. So they kind of created a framework inside their own SDK, which is very similar to futures. And for example, that's a future, and then it says continue with another future, and then it performs some kind of operations. And here we have another future, continue with another future, etc. Now, all this code is quite ugly, and usually when I jump into clients' code bases in order to refactor them or fix stuff or add features, I try not to change the structure of the code. I try not to change the conventions that developers chose to use, because that's usually not my job unless I refactor the entire code base, of course. But here I will actually go and refactor this method before I introduce the change that will fix the bug. And the reason for that is, well, there are a couple of reasons. First of all, it will be very difficult for me to understand what's going on here before I refactor this method. And then this video is educational, so no reason not to show how to do that. And the end result will clearly show the benefits. And in addition, I'm not going to change anything about the external API of this method. So that refactoring will be absolutely internal implementation of this class, and therefore it shouldn't affect anything. And there's really no reason why folks that maintain this SDK wouldn't accept my contribution, this refactoring. So let's go and refactor this class. First of all, this task call executes call and then adds another task after this first task completes. Now, what this first task does is simply checking whether this cache file exists. And therefore, theoretically, I can remove that. Basically, I can do the following. Instead of fetching the result of the previous call here, I can just do the following. Cache file exists. So if cache file exists, I immediately return this cache file. Otherwise, I proceed with the logic down there. And this thing isn't needed anymore. And in fact, this entire task isn't needed anymore. So instead of doing this with continuation task, I will just grab everything inside this task, right? And then I remove this continuation. And now this task call has multiple variants, and I want to use this variant with the callable. Okay, first variant, callable, and then executor. And executor is very similar to what you could see in RxJava or flows or whatever. That's just basically the control of the concurrency level. So I go and create a new callable here, just paste here everything that I copied from the previous implementation. And right away, you can see that I reduced the indentation level of this code by a lot, and we will continue to do that until we can clearly see what's going on with this algorithm, because all of that are just kind of unneeded complications, and I'm pretty sure we can do much better than that. So let's resolve the errors. First of all, this callable now should return, right? Callable returns the result, and the result is actually task file. So this callable should return a file. So here, instead of returning a task, I probably need to return a file, right? Let's just make sure that's callable file. Yeah, I need to return a file. So, okay, I return file, and here, if it's canceled, I want to maybe throw new cancellation exception. Now, this exception is thrown inside multiple methods inside Parse SDK, so I'm pretty sure that that's kind of a standard way to show cancellation inside this specific code. Okay, now we create new file, then create a request to get the file and write it into this temp file, and then we execute this request using the same framework, these tasks. And really, all of this code is very complicated, but what's going on here is really simple. We want to check that this file exists. If it exists, then we just return it. If not, we check whether this flow has been canceled already. And if it was canceled, we just throw cancellation exception. And then if not, we want to fetch this file. We get the location of the temp file, fetch the file, download the file into the temp file. Well, actually, we create a request to download. And here we execute this request asynchronously. And then we add another task after this download, which goes and once again checks cancellation. That's basically a cooperative cancellation, which you must implement in any asynchronous flow. So very good for these guys that they took care of cancellation in this very correct manner. And then we say that if the task one is faulted, basically if this task that should have downloaded the file faulted, then everything just basically failed. We want to delete this temp file and then return task one cast. That's basically some kind of a conversion of the result. We will deal with it later. But if this task that downloaded this specific file hadn't failed, then we proceed and delete cache file first of all. And there's this command: since we give the cache file pointer to developers, it is not safe to guarantee cache file always does not exist here, so it is better to delete it manually. Otherwise, move file may throw an exception. To be honest, I'm not sure I agree with this approach. Something here feels brittle to me, but that's not the bug that I want to fix. And this code has been working so far, so I don't see any reason to delete either this command or fix the code, so that's fine. And then we move the temp file downloaded here into cache file location and return this task for result. But since I refactored this code, we shouldn't return tasks anymore. And actually, I want to simplify it a little bit even more. So here we execute and then we add another task. Basically, we want to have a serial execution. We want to download this file and then just run this code. So there's really no reason to complicate stuff. Just remove all these things. We don't really need them, right? All this code should just run sequentially on a background thread, so we don't need all these complications. Here, instead of returning, I want to use basically the same method I used here. I remind you, when I wrote this unit test, well, when I copied it from the existing unit test, we have this, where is that? Parse task utils wait. This method basically converts some task into synchronous call. So that's exactly what I want to use here. I want to use parse task utils wait, and then I don't need this execute, I just need this request, right? Let's do it like that, and maybe break the line to make sure everything is indented very beautifully. So this wait call will basically just wait for the completion of this specific task that downloads the file. And once it completes, we want to proceed further and check whether the top level task has already been canceled while we download the file. And if yes, we throw cancellation exception. Otherwise, we want to check whether this download failed. Okay, and here's something that will be a little bit more difficult to do. What I want to do here is to check whether this task failed. And currently I don't do that. So let's just do it like that. Task, and this task should return response. Okay, let's just make it like that. Task download. Task equals that. So this will be my download task. I just need to make sure that I put here the correct, okay, this task is void actually. It does not return anything. It just downloads stuff into this temp file. So I don't want anything returned from here. And here I want to wait for this download task, of course. And here, once I have a pointer to this download task, I can check whether it was faulted. And if it was, now I don't want to return task. I want to throw an exception from this callable. So throw exception, runtime exception, and task, once again, download task, get error. That's something that I looked up, how tasks handle errors. So this get error will return me an exception. But since I cannot throw checked exception from within callable, I need to wrap it into unchecked exception, runtime exception in this case, and I think this should work. Okay, all this code became red, so there's the problem. Casting problem. I need task file and I have task object. So somewhere I do not return task. Okay, here I don't need a task. This callable should just return a file and everything becomes great. So once again, just notice this code should theoretically be exactly equivalent to what we've had before, but just notice how much simpler it became. Now you can actually read and understand this algorithm. I can even just, take that and put it right inside this callable. So fetch async creates a new task, and this task will be called on parse executors IO just like before. And the code that will be executed on a background thread is the following. Check whether cache file exists. If yes, then just return this cache file. Then check whether cancelled. If yes, then throw cancellation exception. create temp file, create the request, create this task that gets the file, that downloads the file, and wait for this task to complete. After it completed, we just check for the cancellation once again. And then if it's not canceled yet, then we just go and check whether this task, whether this download task completed unsuccessfully, whether there was an error, and if there was an error, we throw an exception. Otherwise, we just go and perform all this logic. Notice how much simpler the code became. And in general, these kind of refactorings, they're kind of risky because you wouldn't know exactly whether you managed to preserve the existing functionality. But since Parse codebase has unit tests, I can just run all these unit tests again to make sure that they pass. And if they pass, then my refactoring did not change the functionality. At the very least, it did not change the functionality that these unit tests cover. And I hope that they cover pretty much everything that's important. I have this unit test fails, but that's the new unit test. So this refactoring shouldn't have fixed my new unit test that I added, and therefore it's okay that it fails. I haven't fixed it yet. That's fine. I just refactored all this code. So after the refactoring, let's commit the changes. All right, git status, and I already have one new commit here. And the reason why I have one new commit here is because I committed the unit test that I wrote, but now I have changes inside this class, parse file controller, and the changes are just like we've just seen. I removed, just notice how much simpler this code became, even in terms of indentation. I removed all this ugly indentation and the code became much simpler to read and write. That's something I do for my clients often when I refactor their code bases, and this simple change is absolutely amazing. So let's add that and say the following: get commit, and the message will be refactoring the internal implementation, simplifying the internal implementation of fetch async method of parse file controller. Okay, so that's my commit message. And if you just wonder what changes do I have inside build Gradle, I had to comment out this specific instruction because for some reason it caused unit tests not to be run. So I commented them out. All right, now after I refactor this code, I can proceed to fixing the bug itself. I remind you that I have this failing unit test, and I'm sure that if I can make this unit test green, then the bug is fixed. How can I fix this bug? Well, I will need to play a little bit with concurrent constructs. And luckily, this parse file controller, as we've already seen, is a global object. There will be just one instance of it, so I don't need to care about that. And in addition, it already have a lock object, so I can just reuse this lock object. No, let's just have a look where it's used. It's used here to get file client, and here, right? Just two usages there was. Yeah, here and here. Just some usages related to file client. I'm totally fine with reusing this lock. But in addition to this log, I will need to keep track of files that are being downloaded. How can I do that? Well, I can, for example, private final, let's say a list of a string, right? And that will be, import it, please. Yes, thank you. That will be downloaded files, and that will be new array list. Okay, so I will have this array list, which will keep references to names or URLs of the files that I download. Let's see what I have: name, URL, and content type. Well, content type is kind of relevant here, I think, but I need to decide whether I use names or URLs to store my files. Well, we'll see in a second. Okay, here I get cache file for this state. Let's see how it's used. Okay, I just create a new file which reuses state's name. And since I reuse the name here, then downloaded files names. So I will just store names of the downloaded files here inside this temp cache. Okay, what do I want to do here? Well, what I want to do here is the following. The first caller to this fetch async for the file will just enter and start downloading, and the second time this method is called, the second caller will also enter and start downloading, and then somewhere here where they delete quietly or move file, something will go astray and I will get that specific exception that you've already seen, or maybe even before, because I will use the same temp file, right? Temp file is also created using file state. Okay, for temp file, I'm using URL. Interesting. Here they use name and here they use URL. Well, it's kind of strange, but I guess if it works, then it works, and they have unit tests, so I guess it works reliably. Anyways, what I want to achieve here? Well, I want to achieve the following flow. The first thread that calls to this fetch async starts downloading this specific file. And then if the download hasn't completed yet and the second thread calls to this fetch async, then the second thread should become blocked until the file is downloaded. And after it is downloaded, the second thread should unblock and just use the same cache file, because the download stores, eventually it writes right here down here, eventually it writes the downloaded file into this cache file location. So the second thread which was blocked, when it unblocks, hopefully this cache file will exist and it will be able to use this cache file. Okay, that's what I want to do. I want to block the second and third, whatever, calling threads until the download is complete. And to do that, I will need, of course, to synchronize my code, because that's multi-threading. So synchronized log. And what I want to do here, well, I want to make sure if downloaded file names contains, and let's say that will be state name. We decided to use names, remember? If downloaded file names contain state name, this means that this specific file is being downloaded right now. It hasn't been downloaded yet. And therefore I need to do what? I need to send this thread to sleep, just like that, right? And well, actually not just like that. I want to do this while. Okay, so while this file, this specific file is being downloaded, this specific thread will go to sleep, and it will get out of this while loop only after this file is downloaded. So I want to proceed, and what do I want to do? I want to add to state name. However, that's not exactly the case, because if, okay, I need another if here. If downloaded file names contains state name, then I indeed go and I enter this while loop, basically waiting for this file to be downloaded. But if this file is not in this list, then I want to go and execute the same logic that used to be here. So I just check if this file if this cache file exists, and if it does exist, then I simply return this cache file, and that's all. But if it doesn't exist, right, else I want to start downloading it. So that's the logic that I want to write here, if I'm not mistaken. Once again, I take this log and then I check whether I'm downloading, whether the SDK currently downloads this specific file. And if it does, then I wait, this thread, the calling thread will wait for this file to be downloaded. We will handle this mechanism, wait and notify a little bit later. Currently it just waits, but there should be some notification, of course. But if this file wasn't downloaded, then I go and do that. I don't like it because previously this check happened whether, okay, I see. So this should happen regardless. That's not else. Okay, the first thread that enters this synchronized block will just, this will be false. So it will just go ahead and check for the existence of cache file. And if cache file does not exist, it will start downloading it. If it does exist, it will just return it. The second thread that enters the synchronized block will be blocked here until the file is downloaded. And then it will once again check whether the file exists and return this cache file if it does, and go for the download, another download if the file does not exist. Yes, this I think is much more correct logic in this case. And then I proceed with all this pre-existing logic, because I check whether this calling task was cancelled and all the rest. So basically that's the download code. That's basically downloading this specific file. But at some point, once the file is downloaded here after I return, I want to call lock notify all to make sure that all waiting threads have a chance to check whether I'm still downloading that specific file that they wait for. But in fact, I don't want to just do it here after I return this file. In case of a successful download, I also want to do it here and here, basically on each point where this specific flow can end here as well. So I can add this code in all these places, or I can do a little bit simpler approach and then just say finally, whatever happens inside this code of block, finally, I want you to take this log and notify all the waiting threads. So what will happen is that the thread that enters this block of code that basically goes to download this file will attempt to download it, and regardless of whether it succeeds or not, it will notify all the waiting threads. And if any thread is waiting here, being blocked here, it will, well, that's not enough. It will awaken, of course, but it will check that downloaded file names still contains this state name and will go to sleep right away. And I think I can show you that by just running this unit test. It should basically not complete now, because that thread will be blocked forever. And as you can see, this unit test does not complete because the second thread that calls to this method is blocked here forever. And the reason it's blocked here forever is because I forgot here to do the following: download, remove, and then here I need to do what? I need to remove name, right? We used names. So now if I rerun this unit test, and voila, all 15 tests passed, including my new test. And what does it mean? Well, hopefully it means that this change that I performed actually resolved this problem. And now when this fetch async method is called from two different threads, then this new code actually manages the interdependencies between these threads, and the second thread will just wait for the first thread to complete the download and then use the same file that the first thread downloaded. And that's exactly what I wanted to achieve here, of course. Now let's just maybe make some little bit of cleanup. Just put it here. Downloaded files names. Downloaded is not exactly a good name because currently downloaded, right? I want loaded. I want to make sure that whoever reads this code understands that this list will just store the information about the files that are being downloaded right now, not files that had been downloaded in the past. Okay, except for that, I think everything is good. You know, I added this code and I added this code and try finally around this section of code. I think I could maybe break that into several methods, but that will be actually not very good because I think I will change kind of the coding convention used inside this project. That's something I don't want to do. There was one single method before, there's one single method now. I just changed, simplified actually its internal implementation, and then added some concurrency code that fixed that bug that annoyed me. Once I did that, let's just commit everything. So git status, once again, I want to commit just this one single file, and that will be fixing bug. And then I want, okay, let's just this commit fixes number. Okay, now I want to put here a reference to that GitHub issue, because GitHub can automatically infer, not infer, but it can automatically create links between pull requests and issues. And that's exactly what I want to do right now. Okay, where's the number of this issue here? 1155. So I write this commit fixes issue number 1155, supporting concurrent download of the same parse file from multiple threads. Great. And now actually, if I'll do git log, we will notice that I have this origin master, the latest commit inside Parse SDK for Android, and then I have 3 different commits myself. And I don't think I actually want to leave these 3 commits. Actually, I think that what will be better is to do a rebase and just do it like that. From this specific, you have unstaged chain, please commit or stanch. Okay, let's see what's going on here. Okay, so stash that for a moment, git rebase once again. Emacs opens up, and what I want to do is to do the following. I want to reward this commit, and then these 2 will be fix ups, right? Fix up. And then I just want to copy that, because once I close my editor, it will ask me for a new description for this commit. And for some reason, it wasn't copied. So maybe let's go back here. And this commit, multiple threads, back here. Yep, that's the description that I want to have here. This commit fixes 1155, supporting fixes, okay, bug fixes 1155, supporting concurrent download of the same parse file from multiple threads. Yeah, that's a good enough description. And if I'll do, let's just clean everything. If I'll do git log right now, we'll see that I have this latest commit on origin master, and my master has just 1 single additional commit, bug fix, and then fixes. Maybe just, git commit amend. I missed a space here. Okay, and now it looks much better. Bug fix fixes 1155. Now I already set up my remote, git remote -v. That's my repository. So if I do git push, then I will be pushing into my own repository, right? Password. Amazing. And now I just need to open a pull request. All right, that's my fork of Parse SDK for Android, and GitHub already tells me that I have 1 commit ahead of, Parse community master. But before I create a pull request, I want to be a good citizen and find their contribution guidelines. Here, contributing. We want, contribution guidelines. We want to make contributed first as early. Okay, we activate, fork the repo. Cool. Add unit tests for any new code you added. If you've changed APIs, update the documentation. Haven't changed anything, so that's great. Ensure the test suite passes. Okay, I forgot to do that. I will run all the tests now, and then make sure your code leans by running Gradle spotless apply. Okay, compatibility, following to ensure compatibility for the Parse Android SDK. I haven't touched anything about compatibility, and reporting an issue, code of conduct. I think I'm fine. I just need to ensure that all tests pass, not just the tests for that specific class that I enhanced. And then I need to make sure that spotless apply also runs. I will do it right now. So go and execute all the tests. Hopefully this will not take an hour. And I don't have any tests, and the reason why I don't have any tests, that's exactly that specific change that I showed you. So you need to go here and just comment out this code. It doesn't work on this latest version of Android Studio. I don't know why. I don't have any energy to explore that. That's just the simplest solution that I found. And now we see that tests run, and I already have failing tests, actually 3 of them. Interestingly, none of them are related to my code. I just wonder, maybe they have flaky tests. Let's rerun this test suite again, see maybe other tests will fail. 450, maybe there are more. Yeah, there are more tests. Let's see what's going on. And all tests passed. Yeah, indeed, it looks like they have flaky tests, or maybe some kind of a dependency that makes the first pass not work. And I will run spotless apply in the background. You don't need to see that. And then we will get back to contributing. All right, so spotless apply finished. And then I go back to my fork of Parse SDK for Android, and I can create open pull request. Yes. So supporting concurrent download of the same Parse file. I usually do it like that. I don't know why GitHub breaks that into multiple lines. And new pull request checklist. They have, please check the following boxes, click preview. Okay. I'm not disclosing a vulnerability. No, I'm not. I'm creating this pair in reference to issue. Add a brief description of this issue, related issue, fill this out. Okay, is number 1155, right? That was the issue 1155, yes. So that's great. Add a description of the before, add tests. Yes, I added tests. I don't need to change anything. Change log using pull request, no problem. Approach, okay. This PR simplifies the logic of fetch async method and then adds concurrent code that blocks the second and further calling threads until the first thread finishes the download of parse file or fails to do so. Okay, so that's exactly what I did, and let's create this pull request. Okay, I will leave that to the maintainers. If they like this pull request, they will be able to change the title according to their own conventions. I'm not really sure what this wants from me, but this completes this task from my point of view. I hope they will accept my changes. Okay, so there's the changes. These are the changes in parse file controller, and these are the changes in parse file controller test. So basically just 2 files changed, and hopefully they will accept my pull request. And this pretty much completes my contribution for this bug fix. As I said, I really hope that Parse folks will just accept my contribution and there will be no rejects. So I hope that you learned something from this video and it was interesting. And with that, until the next time, goodbye.